This video covers the beginning of Unit 3, Balancing Equations. Chemical reactions are when atoms are rearranged to form different substances. A chemical equation is a balanced representation of a reaction. And when I say balanced, what I mean is there's the same number of atoms at the beginning of a reaction on the reactant side as there are at the end of a reaction on the product side. And this should make sense because of the law of conservation of mass. The law of conservation of mass says that matter is not created or destroyed, so you should have the same amount of matter on both sides of a reaction. So what we're going to do is learn how to balance equations so that we have the same number of atoms on both sides of a reaction. Before I show you how to balance an equation, let's review what chemical equations look like and some of the things you'll see in an equation. Some equations will include the phases of each substance. S means solid, L is liquid, G is gas, and AQ means an aqueous solution. Chemical equations also have an arrow that separates the reactants and the products. So the reactants are on the left, the products are on the right, and there's an arrow in the middle called the yield sign, so reactants yield products. The other thing you'll see in an equation are big and small numbers that tell you how many atoms there are. The small numbers are called subscripts, and they tell you how many atoms are in a molecule. The bigger numbers are called coefficients, and they tell you how many molecules there are. So I'm going to use the same example I did from Unit 1. Water is H2O, which is oxygen and 2 hydrogens, and they're all stuck together in a compound, like this. Now if I add a bigger number in front, that means that there are 2 water molecules. So if we count the total number of hydrogens in 2 water molecules, it's 1, 2, 3, 4. But let's say you don't want to draw it all out. You can also multiply the coefficient by the subscript to get the total number of atoms. So 2 times 2 equals a total of 4 hydrogens. And 2 times 1, I know there's no 1 there, but no number there just means 1. So 2 times 1 means 2 oxygens. 1, 2. So again, we're multiplying the coefficients and the subscripts to get the total number of each atom. This is an example equation, and we're going to label all the parts of it so you have something you can refer back to. The reactants are on the left. The products are on the right. The big number in front is the coefficient, and the small numbers are subscripts. And I chose this equation because it has all 3 phases in it, so solid, liquid, gas, and an aqueous solution. I also wanted to point out that the phases are in lowercase letters and they're in parentheses. So this means solid calcium, not calcium with sulfur. So don't mistake the phases for elements. I also wanted to point out that there's only 1 coefficient here. But if there's no number in front, that just means that there's 1 of them. When you write out equations, you can include the 1 if you want, but if there's nothing there, it means 1. Just like the subscripts, if there's no number, it just means that there's 1 of them. There are 3 steps to balancing equations. Step 1, write out the equation. Step 2, add subscripts. And step 3, add coefficients. We're going to start with the last step because it's the easiest. So we're going to start with the equations already written out with the subscripts in them, and we're just going to balance the equation by adding coefficients. So let's do some examples. The first example is carbon reacting with oxygen to make carbon monoxide. Remember, your goal here is to make the same number of atoms on both sides of the equation. So separate the reactants and products and count the atoms on both sides. We have 2 oxygens on the left side, but only 1 oxygen on the right side. So I'm going to fix that by putting a 2 coefficient, and this means 2 oxygens on the right side. We now have 2 oxygens on the left and 2 oxygens on the right, so it's balanced. Now this coefficient 2 also means that we have 2 carbons on the right side. So I'm going to fix the other side by putting a coefficient of 2 on the left side as well. We now have 2 carbons on the left and 2 carbons on the right, and we have 2 oxygens on the left and 2 oxygens on the right. That means that our equation is now balanced because we have the same number of atoms on both sides of the equation. Notice how there's no coefficient in front of the O2. That just means that there's one O2, so we can leave it blank if you want, or we can fill it in with a 1. Our next example is hydrogen reacting with nitrogen to make ammonia, or NH3. Separate your reactants and products and count the atoms on both sides. There's 2 nitrogens on the left, but only 1 on the right. So I'll put a coefficient of 2 to make 2 nitrogens on the right side as well. So this means 2 nitrogens, but it also means 2 times 3 hydrogens, or 6 hydrogens. So to make 6 hydrogens on the other side, I'll need to put a coefficient of 3 because 3 times 2 equals 6 hydrogens. That gives us 6 hydrogens on the left and 6 hydrogens on the right, and 2 nitrogens on the left and 2 nitrogens on the right. We have the same number of atoms on both sides of the equation, which means our equation is now balanced. Again, if you want, you can fill in the 1 in front of the nitrogen, but if you leave it blank, it just means one of them. The last example is methane, or CH4, reacting with oxygen, yields carbon dioxide and water. Now this example is a little bit trickier because if you notice, the oxygen is split into 2 different places on the right side of the equation. So I'm going to suggest that we start with the carbon and hydrogen first and leave the oxygen till last because it's split in 2 different places, and that makes it a little bit harder. Separate your reactants and products and count the atoms on both sides of the equation. There's 1 carbon on the left and 1 carbon on the right, so the carbons are already balanced. There's 4 hydrogens on the left and only 2 on the right. So I'm going to put a 2 coefficient in front of the hydrogen because 2 times 2 equals a total of 4 hydrogens. Now that our carbons and hydrogens are balanced, let's move on to the oxygens. The total number of oxygens on the right side are 2 oxygens here and 2 oxygens here, for a total of 4 oxygens on the right side of the equation. That means that we need 4 oxygens on the left side of the equation as well. So I'm going to put a coefficient of 2 because 2 times 2 is a total of 4 oxygens. That means that we have 1 carbon on the left and 1 carbon on the right. We have 4 hydrogens on the left and 4 hydrogens on the right. And we have 4 oxygens on the left and a total of 4 oxygens on the right. Again, the oxygens on the right side are split into 2 different places, but the total is 2 and 2 together make 4 oxygens on the right side of the equation. Again, if you want, you can fill in the 1s instead of leaving them blank. Okay, that's it for balancing equations. You have 2 pages of practice problems to do, pages 7 and 8. It's a lot of problems, but the more you practice this, the easier it will be. And I want you to get as much practice as possible before we start the hardest stuff. As always, let me know if you have any questions, and be sure to check your answers with the answer key during class. Good luck!